Today we discuss microwave engineering. In the microwave engineering, first we discuss about introduction of microwave. In the introduction, we discuss about what is a microwave and its application. And we also discuss different type of frequency band that we use for microwave frequencies, just like a high frequency, very high frequency, ultra high frequency, LS, CSK, UKA. These are the microwave band generally used for different applications. And after that, we discuss about microwave devices. There are different type of microwave devices that use for different applications. Depends on application, they are used just like a microwave cavity custom, reflex custom, multi-cavity magnetron, traveling wave tube, gun diode, impact diode, taper diode, and the pin diodes. These are the microwave devices of different applications. Where we discuss in the when we discuss the microwave devices, and that time we discuss about the different type of devices. After that, we discuss the waveguide. Waveguide, first we discuss what is a waveguide and different type of waveguide generally used, rectangular, circular, different waveguide generally used. And after that, we discuss the mode. We discuss the mode of waveguide. Mode means wave pattern of wave inside a waveguide. Then after we discuss the propagation constant of rectangular waveguide, propagation constant generally there is a beta. Propagation constant we discuss when we discuss about the waveguide. After that, we discuss the cutoff wavelength, guided wavelength, cutoff wavelength. Is a that wavelength, particular cutoff frequency. After that we discuss means the particular frequency. Beyond that, no frequency are propagated. And after we discuss the relationship between the three stage wavelength, means cutoff wavelength, guided wavelength, and the free space wavelength. There are three type of wavelength that we discuss during the waveguide. And there are different type of propagation mode in the waveguide, that is the TE mode, TM mode, and TEM mode. That one is TEM mode. First, we discuss the introduction of microwave. Basically, microwave are the electromagnetic wave. Microwave are the electromagnetic wave that having wavelength from 1 meter to 1 millimeter. Electromagnetic wave means microwave frequency range is like from 300 megahertz to 300 gigahertz. This one is the microwave frequency. Generally, this is a very important question, and everyone that is working on microwave field is also known that a microwave frequency range is like from 300 megahertz to 300 gigahertz. In terms of wavelength, it is vary from 1 millimeter to 1 meter to 1 millimeter. As you can see there, 1 meter to 1 millimeter. In terms of wavelength, what is the wavelength? Basically, wavelength is wavelength we define in terms of frequency. Wavelength lambda equal to c by f. Yeah, c is the speed of light, and lambda equal to c by f. As you can see, lambda equal to c by f. Here's lambda. This one is the wavelength. This one is speed of light, and f is the operating frequency. This is the basic wavelength. What is the wavelength? As we described here. And the frequency is like 300 megahertz to 300 gigahertz. And after that, we discuss the different sources and different frequency range at microwave and definition of microwaves. You can see here. A more common definition of radio engineering is the range, means RF, radio frequency range is like from 1 gigahertz to 100 gigahertz. This is the radio frequency range. And in terms of wavelength, it is vary from 0.3 meter to 3 millimeter. As you can see here, 3.3 meter to 3 millimeter in terms of wavelength. And after that, here for our super high frequency band is vary from 3 to 30 gigahertz range in terms of wavelength is like from 10 to 1 centimeter. There are different frequency bands generally defined in terms of frequency. Means IEEE radar band is S band, C band, S, SKU, KKA. These are the IEEE band. And in your syllabus, these bands are defined. As you can see in previous slide, these are the IEEE band. These are the IEEE band. S, C, X, K, U, K, K. These are the IEEE band. There are and similar of these band, there are different type also band available. Means NATO is defined different band. European Union is also defined different frequency band. And but in your syllabus, basically defined S, C, X, K, U, K, K band. These are defined. These band are designed by the IEEE. Here prefix micro is the microwave. Microwave is not meant to suggest a wavelength in the micrometer range. Rather, it indicates what indicate this one. It indicates that microwave are small, having shorter wavelength. Means it consists a small wavelength. That's why its name is micro. Compared to the radio waves used prior to microwave technologies. The boundary between the far infrared, terahertz radiation microwave and ultra high frequency radio waves are fairly arbitrary and are used various between different field of studies. Microwave table. Now we discuss here microwave table by line of sight. There are different type of wave propagation, means electromagnetic wave propagate, or electromagnetic wave or microwave wave propagate different type of propagation in the free space. Means there are line of sight propagation and ground wave propagation, sky wave propagation. Now I think I am also given some introduction about this wave of propagation. Means ground wave propagation, the waves are propagated through the Earth's surface, Just and in terms of line of sight, means if transmitter and receiver both are, suppose if this one is transmitter and this one is receiver, this one is the Earth, this one is the antenna, and this one also antenna. Then this one is a line of sight. Means both antenna are in front to each other. Means line of sight. This one is the line of sight. This one is the line of sight. Not clearly indicated. Basically, I have to draw this one. This one is antenna. This one is the antenna, and this one is the Earth. These are the line of sight. As you can see here, this one line of sight. Next, we discuss about microwave frequency spectrum. These are the line of sight here discussed. Here, it is indicated that terrestrial microwave communication links are limited by the visual horizon to about 100 miles. Means in a line of sight propagation, these are limited to the 40-mile distance. After that, there is very loss occur due to the curvature of the Earth. Means as we know, the curvature of Earth is some in this way, not a line of equal line, and because Earth is in a round surface. Microwave spectrum. These are microwave spectrum. Means ionizing radiation. These are the ionic radiation frequency range is given here. This one is frequencies. Here ionized frequency range. Here visual frequency range also given here. Near ultraviolet, near infrared, and the mid infrared, and these are the visual frequency range are given here. And after that, we had given the extremely high frequency, super high frequency, ultra high frequency, very high frequency, medium frequency, low frequency, very low frequency. These are the frequency are given here. Microwave frequency, microwave and radio frequencies are here. Ultra high frequencies, this one is the ultra high frequencies, and ultra high frequencies support low frequencies, extremely low frequencies. These are the super low frequencies and the extremely low frequency are given here. You can see here super low frequency, ultra low frequencies and super low frequencies and extremely low frequencies are given here. And its range like 3 Hz to 30 Hz, 30 Hz to 300 Hz, as we 3 to 30, 30 to 300, 300 Hz, 300 to 3000. 3000 means 3 kilo. 3000 means 3000 means 3000 means 3 kilohertz. And 3 kilohertz to 30 kilohertz, 30 kilohertz to 300 kilohertz, 300 kilohertz to 3 megahertz, 3 megahertz to 30 megahertz, 30 megahertz to 300 megahertz. Yeah, we can easily remember these things. Means 3 to 30, 3 to 30 hertz, 30 to 300 hertz, 300 to 3000 hertz, 3000 means or 3 kilohertz, 3 kilohertz. Yeah, and 3 kilohertz to 30 kilohertz, 30 kilohertz to 300 kilohertz, or you can see in the above slide. Here, 30 to 300 kilohertz, 300 kilohertz to 3000. 3000 kilohertz means 3 megahertz in term of, it is easy to remember. Yeah. Now we discuss the microwave spectrum. These are the microwave spectrum. Means here the visual frequency range are given here. You can here live from 430 terahertz, and its color is indicator red, orange, yellow, green, blue, and violet in the visual frequency range. Yeah, and here this one is the radio frequency, microwave frequency, infrared, visible, and ultraviolet. This one is the radio, microwave, infrared, visible, ultraviolet, X-rays, and gamma rays. And this one is the visible frequencies band having different color: red, orange, yellow, green, and blue, and violet. And microwave band, there are different types of microwave band. Means L band, microwave band is a microwave band, L band, S band, C band, and X band, and Ku band, K band, Q band, and U band, and U band, and B band, W band, F band, and D band. These are the different band or microwave band. And its frequency lies from 1 to 2 gigahertz. L band frequency lies from 1 to 2 gigahertz. In terms of wavelength, it is varying from 15 centimeter to 30 centimeter. And S band is frequency from 2 to 4 gigahertz. In terms of wavelength, it is from 7.5 centimeter to 15 centimeter. Here the wavelength is lambda equal to C by L. C is the speed of light. C is the speed of light, and these are the wavelength. Means wavelength. And here this one is the frequency. And C is the speed of light. And this is very important band for the mostly they are used for radar, satellite, and high frequency applications. And Q band, K band, these are the frequencies. This one is the frequencies, and this one is the wavelength. Frequency, wavelength, all the bands. And this one is the also frequency, V band, frequency. V band frequency lies from 50 to 75 gigahertz, and W band frequency lies from 75 to 110 gigahertz, and F band and D band. These are the micro frequency band. This is very important band. There are some advantages of the advantages and disadvantages of the microwaves. First, we discuss the advantage of microwave. What is the advantage? Larger bandwidth means the bandwidth of microwave is larger than the common lower frequency radio wave. Means microwave consists a large frequency bandwidth compared to the lower frequency band. This one is given here. Thus, more information can be transmitted using the microwave, and we can easily transmit more information for the microwave frequency band. Generally, at the lower frequency band, there is very limitations. Generally, at the lower frequency band, as we go toward 900 megahertz is used for 2G, 1800 megahertz used for also 2G, 900. There are different lower frequency band means 850 megahertz, 900 megahertz, 18 megahertz, 1900 megahertz, and as you can see 900 megahertz and 1800 megahertz for 2G, and 2100 megahertz for 3G, and also there is LTE band for 4G application means 2300 megahertz and 850 megahertz. These are the used for 4G wireless application. This one is used for 4G. These are the different band that we use for different application. These are the lower frequency band, and for in terms of microwave frequency band, then we use LSCSKUKK band for different application. As we discuss, next slide. What is the application of the microwave? What is the advantage of this one? It is very good advantage. Here, as you can see here you can see it is what happened. Yeah. Okay. Yeah. It is advantage because it is microwave used for point-to-point communication. Only the micro frequency band is used for point-to-point communication, but at the lower frequency band we may also use for point-to-point, but generally micro frequency is used for point-to-point communication because it consists because it consists a directional. It is more directional. And in terms of antenna, if we design antenna for high frequency band, then it is having the more directional and lower beam width. Lower beam width means, more directional means it is only single direction power transmitter, more distance, long distance communication means in terms of directional means in terms of radiation pattern, it is a directional. Yeah, this is the side radiation. This one is the radiation means here. Beam width is narrow, but it is more directional. Yeah, this is direct indicator is directional. That's why it is used for point-to-point communication. And better directivity. It is also same thing. Better directivity means here indicate better directivity means it is power transmitter in a single direction. More power transmitted in a single directional. At microwave frequencies, there are better direction property. It is due to the relation that the frequency increase. As frequency is increase, wavelength will decrease. Wavelength will decrease, then directivity. There is a relation between the frequency and wavelength is that if frequency increase, then wavelength is decrease. As you can see here. Means frequency is increase, wavelength is decrease, and wavelength is decrease, then directivity is increase. Directivity is increase, then beam width is decrease. This indicate, as you can see, this indicate the directivity, and this indicates the beam width. Yeah, this is a lower beam width, but there is a high directivity. This one is high directivity. Yeah. Now we discuss further a small size antenna. At the microwave frequency, as we know that frequency As frequency increase, then wavelength will decrease, and as wavelength decrease, then size of antenna is also decrease. As you can see here, as you can see here, what happening? 1 minute. A small size antenna. As I say that when the microwave frequency increase, then size of antenna is decrease. Size of antenna decrease. Why size of antenna decrease? As the frequency increase, wavelength is decrease. Wavelength is decrease, then antenna size is also decrease. Yeah. The antenna size can be small as size of antenna is inversely proportional to the transmitted frequency. Means there is a bound relation that as frequency increase, then wavelength is decrease, then size of antenna is also decrease. There is a relation antenna inversely proportional to the transmitted frequency. Thus in microwave, we have wave of much higher frequency and hence higher frequency a smaller size of antenna. Due to that reason, at higher frequency, the size of antenna is small. Now, further we discuss the lower power consumption at the microwave frequency. Why? This is also important. The power required to transmit a high frequency signal is lesser than the power required in transmission of low frequency signal. Means in the microwave frequencies, there is as we transmitted microwave signal, then there is a low power is required to transmit as compared to the small frequency transmission. Means higher frequency signal, if we transmit higher frequency signal, then lower power required. If we transmit low frequency signal, then high power required. This one is you can see here. This one is less power required in terms of low frequency signal. And as microwave have higher frequency, thus require a less power. Here we use microwave frequency. Then there is a less power required. Now we discuss further. What we discuss? We discuss here effect of fading. Fading means due to the fading, losses occur. Losses occur. The effect of fading is minimized by using line of sight propagation technique. In the previous slide, we discussed what is means of line of sight. If line of sight means they are in front to each other. Line of sight. These are the line of sight. Both antenna are in line of sight. The effect of fading is minimized by using line of sight propagation technique at microwave frequencies. Here we discuss microwave frequency. While at low frequency signal, the layer around the earth cause fading of signal. While at low frequency, there is more losses occur due to the curvature of the earth. And there are different applications of microwave. There are different applications. These are the application of microwave. These are the application of microwave. These are the application. Application of microwave. There are many industrial and scientific, medical and domestic applications of microwave. The great example of application of microwave is microwave oven. As we all are aware about the microwave oven is a general life application. With the help of microwave, we use different kind of application in the home appliances. As we use microwave in the home, we all are aware about what is the application of microwave. Generally, it is used in the kitchen for heating the food or for cooking the food. We use the microwave oven. Following are the other main application area of microwave. This is the other area: microwave, communication, remote sensing, heating, and medical sciences. In these areas, we also use microwaves. In terms of communication, microwave is used in broadcasting and telecommunication transmission. Means in the cell tower, generally we use for the mobile communication. In tower, in mobile tower, we use microwave for the link. If there is two tower, this one is one tower, this one is another tower, then there is a one circular antenna is given in the mobile tower, and there is also one circular antenna is given here. These are the microwave link. In the microwave link, they are exchange the information. The exchange of information means transmitted and reception. Both information they are exchanged with the help of microwave link. And we have described above the short wavelength and allow to use our smaller antenna. The cellular network like GSM also use. Means same thing. GSM cellular network means tower, mobile tower. We use microwave antenna. Cellular like GSM. Yeah. And microwave frequency of range 1.8 to 1.9 gigahertz for communication. Generally, in the previous slide, we discussed the 1.8 gigahertz means 1800 megahertz. 1800 megahertz is used for which application? For which application? 1800 megahertz is used for 2G application. 1.8 gigahertz means 1800. This is not corrupted. 1800. This one is the 1800 megahertz, or we can see 1.8 gigahertz. Both are the same. And 1900 megahertz, we also use 1900 megahertz for 4G application, and we also use 2.1 gigahertz for 3G application, and 2.3 and 2.4 gigahertz we use for Bluetooth. And there are different frequency bands are used for different applications. Microwaves are also used for transmitting reception of signal from Earth to satellite and satellite to the Earth. Means high frequency microwave frequency band are used in satellite communication, Earth to satellite, satellite to Earth communication. It is also used for military communication. And it is also used for military and army for radar and also communication purpose. Radar also designed for this frequency band, micro frequency band. Remote sensing. In terms of remote sensing, these are the remote sensing. Most of you may be familiar with the application. The most common application of microwave is used in radar and sonar. And radar is used to illuminate an object by using the transmitter and reception to detect the position and velocity. Radiometry is also one of the remote sensing application. Radiometry is also used as one of the remote sensing application. Yeah. And heating. For the heating, we also use microwave frequencies. You all are familiar with this application. We use microwave oven to baking the food, as we know, baking the food, and very convenient to electronic machine. This perform heating task very clearly, and it's very less time. With the help of microwave, we also cook the food. If anywhere need heating, we also generate with the help of microwave frequencies. Food is also one for making the, and also use for medical applications, medical sciences. Microwave in medical sciences, in terms of tumor and and different application and diagnosis and X-ray and MRI. We use the microwave for, and also used for diagnosis and various therapies and heating properly microwave such as drying, cooking, and moisture evening. In term of medical, we use for X-ray, we use for MRI, we use for microwave means for cancer diagnosis uh, and different also different scenario, different not scenario and medical not a limited. There also work is going on and brain tumor detection and breast detection, breast tumor detection. Different application we use microwaves and waveguide. This topic we discuss in the next class, and today we discussed about what is microwave. Today we discuss about the introduction of microwave, and we also discuss the what is frequency band, and these are the microwave spectrum. Means these are the ionized radiation, visible frequency band, microwave, and radio. These are the microwave or radio. These are microwave and radio waves, and we also did microwave EHF. This one EHF. This one is the EHF, super high, ultra high, very high frequencies. The other frequencies, and microwave spectrum. This is the microwave spectrum, and the microwave band that we use for LSCS. These are also microwave band. These frequency band basically defined by the IEEE, and your syllabus also define these band LSCS, KUKA. These are also microwave frequency band, and I also discussed the advantage of microwave: large bandwidth, better directivity, and the small size antenna, lower power consumption, effect of fading. These are the advantage of microwave. And after that, we discussed the application of microwave. There are different type of application of microwave: communication, remote sensing, heating, medical sciences. We discuss also communication, microwave, military, and remote sensing, heating, and medical sciences application. In next class, we discussed about the waveguide. There are different type of waveguide that used for different application. Thank you.